Traditional programming thermostats typically look like these: boring, white, rectangular boxes with many buttons. If you have ever used one, you will know how difficult it is actually to program them. Most users of the programming thermostats either program them incorrectly or just ignore the feature completely due to the poorly designed user experience. In contrast, Nest thermostats provides a simple, effective, and elegant solution, and I will examine the design principles and the user experience models Nest used. So we'll first look at how Nest finds resonance in this problem, which is the current user's frustration with the existing programming thermostats. The first approach is the artist approach that came from the Nest co-founder, Matt Rogers. As a former Apple programmer, he said even with his programming knowledge, he could not program a thermostat. And if it's a problem for an Apple programmer, it would be a problem for many people, which leads us to the second discovery approach, the ethnographic observer. According to many studies, traditional programming thermostats actually have higher energy consumption as the user mostly programmed them incorrectly. The last approach is competitive opportunist, as the Nest developers are trying to improve on an existing poorly designed product. The users of the programming thermostats are obviously homeowners who want to achieve the following three things. First is to know the current temperature in the house. And second is to change that temperature easily. And the third is to schedule temperature changes to suit their lifestyles and to save energy. So how did Nest create value for those users? Let's first examine the design tools used by Nest. Here's a video showing how the Nest thermostat works. There's the focal points to attract the user. When the user approaches the thermostat, it lights up and welcomes the user to interact. There are three key elements on the layout, which clearly shows what the user wants to see: the current temperature, the target temperature, and if the set temperature is energy efficient, as shown by a green Nest leaf. There's also clear contrast on the screen, as blue means cooling, orange means heating, and green means the system is off. So the users do not have to guess what mode the HVAC system is on. The most key design tool used here is simplicity. There's no buttons on the thermostat, no need to program. All you need to do is to turn the dial. The same simplistic design is used for the app interface as well, as we can see here. Even though the product mainly operates in a lean back mode, user can override the temperature settings whenever and wherever they want using the app. In addition, there are significant interactions with Nest with monthly newsletters to show users the savings and how they are doing compared to their neighbors. The product is also consistent in all three behavioral, visceral, and reflective levels, as it delivers a superior user experience for all three minds. On the behavioral level, it uses AI to learn from you and it creates schedules for you without the need to program. On the visceral level, it has an extremely simple and elegant design, using just a dial and a screen. On the reflective level, the product fulfills a greater purpose: energy savings and the environmental benefits. The UX design map is shown here. The attraction starts with motion detection that lights up the screen to welcome the users. The entry starts when the users start turning the dial to adjust the temperature on the screen, with a clicking sound to provide feedback, which is very intuitive. The immersion process starts when the thermostat to learn from your lifestyle and uses your location to preheat and cool the house before you arrive home, so that it maximizes the user comfort. The convergence starts when the AI starts to produce real savings for your bills and also provides benefits to the environment. As the thermostat is simple, effective, and it produces significant savings, it promotes the users to share among their friends, which quickly spreads the product, which is the extension stage of the design. When we look at the 5 E's, first, the product is extremely effective, as AI technology learns from you and creates a schedule that suits you the most, and does so with extremely high accuracy. The Nest is also very efficient. It doesn't require much user input. All you need to do is to turn the dial up and down for the first few days according to your schedule, and that's enough for the AI to learn. You also keep users engaged using monthly newsletters to promote environmentally friendly habits and keep users in check. Nest is also very error tolerant. As there's so few inputs from the user, it's very hard to go wrong. In addition, the users can always manually override whenever and wherever they want. Lastly, the product is very easy to learn. All you need to do is to turn the dial. Nest produced significant savings, which pays for itself within 2 years of use. It's so efficient that the Ontario government is installing them in thousands of households for free. It is a great example of how a well-designed user experience can disrupt the thermostat industry and bring so much value to homeowners and the environment. Thank you for listening, and this is my presentation.